Welcome. In this video, I'll be talking about subsets. Set A is a subset of a set B if every element in A is also in B. And the notation that we use is here. A is a subset of B, or if you want to say A is not a subset of B, you can just put a line through that. So let's say that we have A is defined as 2, 4, and 6, and B is 1, 2, 3, 4, 5, and 6. Then we can say definitely here A is a subset of B because each element in A, 2, 4, and 6, are also here in B. B just happens to have additional elements. So A is a subset of B, but we could also say B is not a subset of A. Let's see. If I were to say that, let's see. C is the set X such that X is a letter in the word math. And D will say that is the set Y such that Y is a letter in the word hypothalamus. Then we can say, let's see, MATH. C, if we were going to use the roster method, it would be the elements M, A, T, and H. And notice that those elements M, A, T, and H are also here in set D. So we can say that C is a subset of D. Alright, so that brings us to our next concept, which is proper subset. So A is a proper subset of B if it is a subset but not equal. So A does not equal B. Remember, equality in set means that the two sets have exactly the same elements. So in this previous example, I could say make a stronger statement that C is a proper subset of D. So it is a subset but not equal to D. If I defined another set F and said F had the elements T, H, A, and M, then F would not be F is a subset of D, but F is not a proper and F is a proper subset of D. The notation here would be this is a proper subset. So notice I'm not taking away the option for equality here. And so F, which contains T, H, A, and M, is a subset of D, and F is a proper subset of D. Now, if I was going to look at set F and then compare it to set C, F is a subset of C. All the elements in F are also in C, but F is not a proper subset. And so to indicate that, I'll just put a line through it of C. It's not a proper subset of C. It's a subset, but not a proper subset, because actually F equals C. The order of the elements, M, A, T, and H, and T, H, A, and M, the order that you place the elements when you're using the roster method is irrelevant. So F and C are the same. And just as a little sidebar, if you repeated elements, that wouldn't make any difference. For them to be equal, they have to have the same distinct elements. So, all right. So let's say we define a set, and we want to know, well, how many subsets does the set have? So let's take this set C and see if we can figure out. So C, if I'm going to use the roster method, has M, A, T, and H as its elements. So the subsets would be the sets that just contain the individual letters, so M, A, T, and H. So those would be the single element subsets. And then we would have the two element subsets, MA, MT, MH, let's see, AT, and AH, and I'm running out of room here. Well, so for the two elements, and TH. So what about the three letter subsets? I could leave out the M, and I would have ATH. I could leave out the A, and I'd have MTH. And I could leave out the T, and I'd have MAH. And I could leave out the H, and I would have MAT. And then, of course, there is the set itself, the MATH. And lastly, the empty set is a subset. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 elements, or 16 subsets of this 4-element set. A shortcut, if you want to just know the number of subsets, you can take 2 to the n, where n is the number of elements in the set. So in this case, n of C is 4, and 2 to the 4th is, in fact, 16. Now, if you want to know the number of proper subsets, in this case, I would not have included the 4-element set, MATH, and so that would be 2 to the n, but minus 1. So there would be 15 proper subsets in this case. All right, let's look at a couple of problems that are in context. So I'm taking this from a textbook where this says I don't know if you can, let me see if I can get that a little bit larger, and if it will focus for us. Yep. Okay. A cheese pizza can be ordered with some, all, or none of the following set of toppings. We've got beef, ham, mushrooms. That's 3, 4, 5, 6, 7, 8, 9 options. How many different variations are available for ordering a pizza? Now, you can have some, all, or none. And so basically we're looking for the number of subsets. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we take 2 to the 9th power, so let's see, 2 to the 9th, let's see, 2 to the 5th, I have memorized, that's 32, 2 to the 6th is 64, 2 to the 7th is 128, 2 to the 8th is 256, and 2 to the 9th is 512. So there would be 512 different variations are available for ordering pizza here. Let's see, a small town has 4 police cars. If a radio dispatcher receives a call, depending on the nature of the situation, no cars, 1 car, 2 car, 3, or all 4. So this no cars would be an empty set. All 4 cars would be the entire set of these 4 cars. And so how many options does the dispatcher have? That would be 2 to the 4th, which is 16. And finally here, film documentaries with the highest box office grosses include Fahrenheit 9/11, March of the Penguins, Earth, Justin Bieber, Oceans, One Direction, and Bowling for Columbine. Let's see, so how many is that? Oh, there are 7 documentaries. And you're going to watch some, all, or none of these films. So as far as your options, you would have 2 to the 7th, which right down here I see is 128 viewing options. All right, I hope that helps with your understanding of subsets and proper subsets. I'll see you next time.